So this video continues the previous video in which we reused a kernel and an inittab fs, or RAM disk, however you would like to call it, and we actually took a tarball of alpine minimal rootfs and extracted it and used it as our root file system. When we did that, our result looked like this. We booted the kernel, and then we were not able to enter anything like to the console because the way inittab was configured, so we fixed it in several ways. The reason I'm mentioning it now and not fixing it, which we will do at the end of some of the solutions that we're going to mention, is that this is going to be the start point for each one of the alternatives that we're going to show for actually populating a root file system. So these alternatives are going to be the first one that we already saw in the previous time that I quickly showed, which is extracting a tarball on top of the root file system. The second one would be something that demonstrates how we can take a partition or a file system and overlay tarball contents, it could be multiple tarballs, on top of whatever there is there. So for example, if it's completely empty, but it is formatted like as in the Linux ext4 or whatever you like, a file system, and we extract a tarball on runtime, not on real, for example, when we install on top of it, then it will achieve the same result. So it will be stuck in the same way. So this allows us to also, for example, if we had something that does work or is stuck, to just add the little difference and with a simple tarball fix a behavior. This is a technique that will allow us, for example, to do live patching, over-the-air update, and so on. The other thing that we will show is a very powerful concept and very important concept when you want to have a root file system that is read-only, and there are very important reasons for that, both robustness of the storage device and an option to be stealthy or cleanable and some other things. But this technique can be also used to do several things. So it's called overlayfs, and I call it writable overlay. So we're going to see three different techniques. One of them we already showed, that is extracting or copying. The other one, overlay tarball. And the last one, I call it writable overlay. So let's see how the implementation looked for the first case. I slightly modified it. We had a pre-pass function that is called from the generic build distro script, where we take a tarball, and if it doesn't exist, we download it. We remove whatever was before in the rootfs dir that will be packed into system.image. And then our first implementation just goes ahead, extracts the tarball, and does some modifications that are modifying a version file and setting the hostname. Important, if we set the hostname file and nobody calls the hostname executable, then the hostname will not be set. So if you have like a prompt that looks at the hostname, it actually asks the kernel, hey, what is your hostname? It's like a system call. So it does not, nobody reads the file. The file is being used in order to set the hostname, and then the kernel actually holds it inside, and then the hostname is exposed outside. But since systemd and other mechanisms actually do this setting of the hostname by file, then you automatically see this, and it's a good practice to populate like the hostname file. So this is the first alternative that we had. We already saw it. The second one will be taking the tarball and installing it, actually just copying the tarball. We'll be copying the tarball into a variable that is called installable overlays dir / the partition on which you want to overlay, which will be system in this case. If you format with more partitions, you can overlay on top of whatever you do. So here we just create a directory if it doesn't exist, and we copy the tarball. Let me build the code, and then we'll see what happens when we install it. So once the build is done and I will install the system, then we can see there is actually a flag that says we like to reformat the partitions, yes or not. But we can see a couple of things. First of them, because I removed the system partition, I do create a system image and just make it empty. So tell me, hey, you're about to make a huge mistake, but I do it deliberately, okay? So I did plan to do it, so we can ignore it. But look what's going on. You see that I copied this tarball, and the name is promising because it's what I've done. It's going to just go ahead and apply the tarball on top of that folder. So we can see that at the end it says done extracting tarballs. It goes over all the tarballs that you have over this folder in the installing media, and it overlaid all of them, extracted them on top of this folder. In addition to that, if the tarball itself on like its root directory of the tarball for the refactor has a file with instructions that I called overlay install instructions, then after the extractions, this file is going to be run. So this can allow you to modify the flow of the system. It can allow you to do live patching, and it can allow you to do all kinds of things, these techniques, not necessarily during installation, but also during the life of a system. So once we're done, we're going to boot this, and the expectation will be to have the exact same behavior as before. So we can see again that this is stuck. Now let's just double check that this was the behavior and this is what we wanted to achieve. There's nothing to double check because I just showed it on the previous one. So we extracted the content of the tarball, this time not while building. The first time we extracted while building, and this time the installer code that I prepared, it actually took an overlay and then it did it. So this is option number 2. Option number 3 is quite interesting, and we will go ahead and dissect it. Okay, so this is the solution. I did not want to show it. So I'm going to comment out this one, and then it's almost identical to the previous solution that I showed. However, this time, instead of copying the tarball, I'm copying only the tarball into the overlays dir. I will, instead of it, copy to a writable overlays dir. So let me save the change and build it. So this time, when I will install it, and now I'll just pause and resume so it will be a little bit faster. Actually, it was very fast. There was no need to do it. Look what's happening. It's going to say, done extracting tarballs from media removable installables. It looks the same, but this time it's writable overlays and not system. And look where it installs it. It installs into mount overlay setup systemrw fsmaterials. And I want to explain a mechanism that's called overlayfs and tell you what I've done. So pay attention. When I will now run the system, and remember that I deleted the previous system partition, this is what will happen. Boom, failed to find an executable init in /mount system. Why? Because I put an empty system partition. It is the truth. This is what I had. And this is like how I formatted it. So that's what I had here. Nothing too important, nothing too exciting. So where did my data go? So the installer already told me, it hinted where it goes, okay? And I will now go ahead and boot it with slightly different way. But before that, I'll just show you where the information went. So there is a partition, and now to make dir blah, mount label equals the name of the system partition, and then I added rw to say, hey, this is like a writable portion, it's another partition. And I'll do blah. And if I go to blah, I have fsmaterials, file system materials. And over there, I have 3 folders. Merged, that now will not have anything. Work, that has work but doesn't really have anything. And the last one, upper, which will contain all of my information. So I can go ahead and copy it into the other partition and we'll achieve this exact same result, right? But then what happens if I want to have read-only file system, as I do now? So the idea is that I can take this data that is in upper the kernel will use another intermediate work directory to do some merging of this upper directory and a lower directory that would be my original mount system, that in this case is actually nothing. Okay? So this is how it looks like. So now, because I already mounted it, because I already saw how things look like, and because I, of course, know how to fix it, I will go and just remove the inittab file here. Let's see if it exists. It does not exist. And I will sync so that the data will be saved. And I will write this again. I will run it again. This time, I will add something called overlayfs into Runtime. Now I made some default parameters that say we're going to overlay this particular partition and this folder over it upper over the system partition that we had. So now you see it even has my changes where I deleted inittab. This is the ask first. So this is what I have. And if I go and do mount, it will tell me, hey, the root file system is overlayfs, and the lower dir is mount overlay setup system, and the upper dir is mount overlay setup systemrw, fsmaterial upper, and the third one is the work dir. By the way, if you like using Docker, you can see that usually Docker, for every run step in a Docker file, it will create such a lower overlay directory. So when you run a Docker, you will see something like this with the mounts, and you will have tons of lower directories, and on top of them you will have one upper directory. It allows you to overlay an upper directory over the unification of the other directories. So this is great. This is interesting. Okay. So what can I do with this overlayfs? What I can do is put something that I actually won't read only. For example, extracting the original tarball on top of the system partition, and then make some changes on the system partition, which is what I'm going to do now. So I'm going to comment out this guy, and then I'll go to the combination solution that calls the first thing for overlaying a tarball. And now look what I do. I create another tarball that I will put on the writable overlay file. And this will make the installer extract the tarball onto the respective partition under the respective fsmaterials folder. And the name is completely arbitrary for the tarball. And look what I put in the tarball. First of all, I'm going to remove it, and I create an etc folder. And I do two things here. The first one is pretty much obvious. Echo haki hostname into hostname. And the second one, I will explain what it is very shortly. Okay? So let me go ahead, and after doing this, what I will do is actually go ahead and create this tarball and copy it into the same path as before to the writable overlays here system. So let me go ahead and build it. So after building it, I'm going to install it. And here I'm formatting the partitions. And look what is going to happen here. So two things here. We have here this system partition, and it is empty, okay? And we're going to make a huge mistake. But here what we do is two things. The first one, and this is something that I actually skipped. The mechanism that I used for the first one was to use the overlay. I did not use copying. The comment said, hey, could also use the copying. So I used the overlay. This is the second solution that we tried, okay? And what I also have here, so we overlaid like before. We'll see the tarball name here, okay? It goes to overlay system. And in addition to it, for the writable, we have the amazing blah blah.tar that finds its way onto the writable overlays system. And then this goes into the fsmaterials here. So it installed, and I want to first boot without overlays. Okay, so I'll boot without the overlayfs. And what I will have here, no console. Okay, this will also happen if I use overlayfs that is like tempfs. But now I will go and use overlayfs like this. And remember that we actually did some modifications. The modifications that we made were to echo hacky hostname and to do this weird thing, make node inittab -m, no permissions, character device, major and minor of 0. So now first let's see what happens when we run it. So surprise, surprise, we now have this, ask first. Now why? What's going on here? So let's see what's going on here. Let's see exactly what's going on here. So what happens is that if I look, this is my root file system. At inittab it doesn't exist, it has initd. If I look at the hostname, that's the hostname, and you know what? I'll just use what I did in the demonstration. I'll just do hostname -f. Voila, hacky hostname, which is what I echoed. It exists here. Okay? So what happened to inittab? So let's see what happens if we go ahead and perhaps delete other files. So right now I'm going to go to etc. And for fun, I'm going to remove a file that is called message of the day, just for fun. And I'm also going to remove the file called nssswitch.conf, and I'm going to echo the PSCG into issue file. So let's cut issue. It says the PSCG. I'm going to sync. Okay, I'm going to do mounting here, and we see that these are the folders that I see. Where do I see them? The upper there is right before I do a switch root. So I will not see this under mount unless I prepare the mount point myself. But I want you to see what happens after I reboot to the RAM disk. Okay, I can mount it now and just do something like I did before. Make dir, let's say blah. It is a read-only file system, okay? It is a read-only file system. So why can I do blah? Because it will do it over the upper. But I'm going to do this mount label equals. So I'm going to do mount label equals system. A lot of time I use that as the writable. Systemrw blah. It says can't open block dev. But you should not worry about it, okay? The reason it says it is because we have an overlay that uses this block dev and it writes into like the same folder here. But whatever you do, unless you put in very specific places, it will work and it's super legit. It's common. This error is nothing. So if I go to blah, I will see the materials that I had before. In merged, I will see nothing, okay? Why? Because I merge it not on this folder, but wherever like I mounted, okay? And I actually go ahead and mount it like over like the root file system here, okay? And this is what I later go and do like the chroot. But sometimes if I don't do like chroot, this is how I will work here. This is some of the reasons like for the block dev issues. Now, work will not be interesting. It takes luck to see something over here. So now we add luck. We actually see something. Okay? So what is this thing? It's a character device that does something. And what does it have? It has 3 links, 3 references. Now let's start this file. Or let's do ls-li. Let's look at the inode. Okay? So we can see that the inode of it is 32010. Okay, fair enough. Now let's go to the upper dir. And remember, blah was created over there as well. Okay? So I'm going to go to fsmaterials. I'm going to go to the upper here. Now do ls-li, okay? And what we can see here is a folder called blah that has like 2 links and etc. All right? By the way, every folder, if it's empty, it will also have like link, okay? Like dot and like dot dot. So this is what we have here, all right? Let's see, we see 1000, it's the user of my host. And we have the inode here that is 32010. Fair enough, this is something on the work directory. So let's go ahead and see what's happening under blah. Nothing is happening, right? But what happens under etc? So if I go ahead and look at etc here, I want you to see this number 32010. It appears several times here, here, and on the work directory. I told you you need to be lucky in order to see something. So this is hard linked to the same thing. Usually you're not going to access the file system where you have like the upper directory just going to go over the merged, and you're not going to mount the same block device over the same file system. So you're actually using the file system while working on it. But the bottom line here is that these are links to the same file, and these 2 files are the files that I deleted, okay? And the concept here matches exactly what I've done here. In order to delete a file, if you delete a file in the merged file system, what happens is that a character block device with no permission and with a major and minor of 0 and with the same name of the deleted file will find itself there. So this is what you see here, and this is why under the root file system you will no longer see etc mod d, okay? But you will see hostname, for example. Why? Because we modified it, okay? So what is the content that we see here? The exact content that we see here under the upper directory. And the same thing goes for issue, okay? The exact same thing goes for issue. And they have different inodes. And here I change issue to this file, okay? And now if on the upper directory I go and remove the host name, then the overlay is done, okay? This was like the read-only portion. Now let me reboot it. I have the overlay, but I don't have like the other one. So etc hostname, now it is localhost, okay? So what is the takeaway from this? The takeaway is that deleting is something that is a little bit tricky when you delete. Why? Because you need to create an empty character device with no permissions. And another takeaway is that when you are modifying the upper directory directly, then there can be inconsistency in the overlay fs. Some things happen when you mount, and the expectation of the kernel is not to go ahead and look what happens every time like in the upper directory. It expects things. Normal procedure will be just doing things on top of the merged. When you're done, you unmount everything. This is why when I rebooted, then we actually saw it. So we actually learned here about overlayfs. We learned about some advanced concepts and some really challenging troubleshooting issues when you use overlayfs and don't understand where things go. And while being on it, so let me show you something more. Let's see what happens if I run it with an overlayfs that is tempfs, okay? So I'm going to use overlayfs tempfs, and I'm going to give it just for fun 100 megabytes. So if I run it like this, again, I will not have like the OpenRC, and it will just not work. Alright, so it says tempfs overlayfs failed, and the reason for it is that it's not supposed to be MB, it's supposed to be M if I want to use the size. Okay, so now we'll not have console, but we already know what is the reason, so I'm going to hack it manually right now. I will just stop at the RAM disk and I will modify the file myself. Mount system without overlayfs, it's easier to remember. And I will remove etc inittab. And I will even say echo hacked them into etc, let's say message of the day, why not? Sync, and then I will just turn it off, and now I will run with the overlayfs of 100 megabytes. So now I can see that I do have console access, alright? And now, of course, I don't have blah from before. It was on the upper. And now look what I'm going to do. I'm going to make dir I don't know. Sorry, I don't know. Okay? I'm going to touch x, y, z, w, v, like vector class. All of them exist. And I'm going to echo run into Munix. So all of them exist. But what will happen when I will reboot the system? This is a temporary file system. And remember that I gave it 100 megabyte. Let's see what is the size that I have here, 100 megabyte. So I could give it more, and I'll do it like on the next boot just for fun. But look what happens when I reboot the system. Where are my files? Nowhere, because they went to a writable tempfs, and it's gone. So this is a way to achieve cleanable system, and for the sake of completion, because I said so, let's do it 1000 megabytes, and I will see, of course, the files are not here, but that this is what I have now, okay, which is pretty nice. And I can also see that this is like the type of memory that I have, and even though I allocated like a tempfs, it's not used, so I'm not filling the RAM. When you use tempfs, you need to be mindful of what happens when it gets full. And if you don't give a size to the tempfs, then by default it will be half of like your RAM size, and this has to do with tempfs in general, not just for using overlayfs. So having said that, we covered the summary of what we've done the previous time. We did the same thing with readable or like overlay tarballs. We did writable overlays with the exact same thing that achieved the same results. We put the tarball, the overlay tarballs, and overlaid on top of them writable overlays, and we learned techniques for actually what happens when we delete or when we change a file. One last thing, it's not that important, but we saw that there was like a link, hard links to the work dir, for example. When we delete something, everything points to the same thing because it's just the same file. Why spend more inodes? So if you reboot this, then a new file is usually created. So if you delete files over different like reboots, you will see that not everybody points to the same file. So having said that, we will conclude here. It was pretty comprehensive, and I hope that you enjoyed and that you learned something. Thank you.